Hey, so this isn't really going to be an instructional video, although I will go over the circuit for this amp and try and explain how it works. I mostly just wanted to show off my build because the tube amp is something I've wanted to make forever, and here it is finally, right? Well, it's a hybrid amp, but I think it counts. So you see the green LED is on now. That indicates that the circuit is powered up now that I've plugged in the input. When I just plug in the power, only the heaters are powered up. So here's what this sounds like just on my phone's internal microphone. So right now the gain is about halfway, which is where I think it sounds the best, and the volume is actually less than halfway. So if I actually crank the volume, it's fairly loud. That's I don't know how much of that is going to come across on the camera, but it's what I would call definitely loud enough to annoy the neighbors if you're in an apartment. It's like a 5 to 10 watt amp, so that's how loud it is. Here's the middle pickup, middle position. I don't really have a very good way to record this, but what I will do is I'll do a line-in recording with an attenuator from the speaker output there, and that'll be at the end of the video. But now, let me put away my guitar, and I'll go over the wiring of it and the circuit and show you how it's wired and what the circuit is, yeah? So I'll be back in just a minute after I've put away my guitar. Hey, so I'm back with a slightly different camera angle. Let me take the top off this and brace yourself for some really messy wiring. But there is the guts of the amp. What I'm going to do is I'm going to draw the circuit and I'll point out where everything is. So okay, let me start with power. Let me turn this okay, there we go. So that is the power jack, the power input jack, and it does run off just 24 volts, so regular kind of wall adapter here, which is a low voltage for tubes, but it's not as bad as it sounds because the tubes I'm using over here, these are 6J1 tubes. They're Chinese tubes and they're pretty much the cheapest tubes on the market. They also happen to be designed for somewhat lower voltages than your average tube, so that's a good thing. Alright, so here I have my 24 volt power input. Okay, that's the positive on the inside, and for ripple filtering I have a buffered RC filter. So there's an RC filter like that, right? But then there is a Darlington's pair of transistors like that. And so what this does is it makes, so you're going to get a smoothed voltage over here, but then this makes sure that you don't load the resistor too much, and so you actually get very good performance out of this. I learned this from EEV blog, and it's apparently called a capacitance multiplier, but it's just a buffered RC filter. And so that's over here. You see, the power input comes in and it goes over here. There's a capacitor and a resistor, and that resistor is a 1K resistor, and this is a 470 microfarad capacitor over there. And the transistors, in case you're interested, this is a BC547 and that's a D882P. And you'll notice that there's a little heat sink on here, and that's sort of important because this then goes to power the entire amp, the entire amplifier. And so you have, one silicon drop, 2 silicon drops times all of the current supply for the entire amplifier. So that's, little over a volt times little under an amp, so about a watt of power being dissipated there in this transistor mostly. And so a heat sink is a good idea, a small heat sink. All right, so now then this goes off to first of all, let's see. First of all, this goes off to a buck converter, and it's just one of these cheap little buck converters you can buy. Let's see, where is it? There it is, over there. You see that? So it's a buck converter module that you can buy at most electronics sort of stores. And so we have a DC to DC converter, and the input is, this is 24 volts, this is, you know, about 23, and then this is set to 15 point something volts. I think 15.3 volts is what I set it to. So this powers the heaters of the tubes. Now the heaters are rated for 6 volts each, and I have them in series, so that would be 12 volts. But the reason I have 15.3 volts here is because I have a resistor in series with them. So I have, that's a 20 ohm resistor, and it's actually it's that over there. It's 500 ohm resistors in parallel, and the reason that's there is because, well, let me draw the heaters. So there's the heater of one tube and the heater of the other tube, right? And these the thing with metals is that they the resistance goes up with temperature, and so in light bulbs and in, you know, vacuum tube filaments, which are really very similar, the initial resistance is low because they're cold, but when they heat up, the resistance gets higher, and so the current goes down. So although the steady state current of these is low enough that, you know, this buck converter as well as my 24 volt adapter can supply, you know, that amount of power, the initial current is very high, and so this is there to limit that, because otherwise the well, the circuit was shutting down. These power supplies were not able to handle that. And then in parallel with this, I have a current limiting resistor and an indicator LED to indicate that the heaters are active. Okay, so yeah, that's a red LED, and then this is 15. That's a 10K. That's a 10K resistor. So now then this comes here, and there is a switch, and this is built into the audio input jack. You know, this switch comes on when I plug the audio input in. And so then this then is the positive voltage rail for the rest of the circuit. And also here I have another indicator LED, so current limiting resistor. This is 22K, and a green LED to indicate that the actual amplifier is active, like that. Oh, I might not have got that in frame. So that's what that is. So now this comes down to here, and this is going to be the positive rail for the actual amplifier, right? So now the input, so let me draw the input. Here is an audio jack. I'll go ahead and draw it like this, and we have a sleeve connection and a tip connection. The sleeve goes to ground. The tip connection goes through a 1 microfarad coupling capacitor, which is a bit oversized actually, but but whatever, and then it goes to the tube. Now the tube, so let me draw the tube, and the tubes typically used in guitar amps are triodes. However, the 6J1s are pentodes. So here's your regular triode. You have your anode, which is a plate at the top, and you have your cathode, and you have a grid, right? So that's your triode, and of course there's the heater, but I've already drawn the heaters over here, so I'm not going to redraw it over here. So that's a triode. But in a pentode, what changes is that you have 2 extra grids over here. So these are, you know, G1, G2, and G3. All right. Okay, so now in addition to being a pentode, the 6J1s are actually sub-miniature pentodes, which as far as I can tell just means that G3 is internally connected to the cathode. All right, and it does have a pin of its own, so just for good measure I've connected it externally as well. So now I'm using the pentode as a triode, and the way you do that is you just connect G2 to the anode like that, and so now you have a triode. There's your anode, G1 is your gate or grid, and then this is your cathode. So now that's a triode. So this goes to the gate. And now there is a biasing resistor to hold it at 0 volts, to hold the gate at 0 volts, the grid, sorry. And this is a 1 megohm resistor. I don't need to show you that, it's a 1 megohm resistor. The capacitor, by the way, that yellow thing, that's the input capacitor, big beefy capacitor, because it's non-polarized 1 microfarad capacitor is quite big. So now there's that, and then I haven't left myself enough room here, but on top I have a fixed resistor as well as a variable resistor. I hope that's clear what I'm drawing there. There's a fixed resistor and a variable resistor. The fixed resistor is 10k and the variable is 470k. So that's the gain control for the amp. And this sets the minimum gain of this first stage. And then at the bottom you have a cathode resistor. This is to provide DC bias, because the cathode needs to be at a higher voltage than the grid. It's like a JFET. And so this then goes to ground, and there is a bypass capacitor to minimize the loss of gain due to this resistor. So this is, let me just remind myself what that is. So that's the resistor. That's not it. It's that one at the bottom there. That one, and that's a 10k resistor. So we have 10k here, and this is a 470 microfarad capacitor. All right, so now that is our first stage. This is the output from the first stage, and this is capacitively coupled to the next stage, which is very similar. So this time, I'll bring this down a little more. This time the biasing capacitor is 10 meg, and this is 100 nanofarad. So the RC time constant is the same in both cases. Again, this could be smaller by an order of magnitude and you'd be fine, but it's whatever, it doesn't matter if it's a bit big. So then this goes to same arrangement like that. This is connected there, this is connected there as well. This goes up like that, and then this that's G1. And so then this again, you have 10k and 470 microfarad there, same thing. And then over here I have a large resistor. So over here I have 10 meg. And the reason that I can get away with this over here, so over here if I use such a large value, that's not going to work out particularly well, because the input impedance of the next tube is not high enough to allow for such a high output impedance on this stage, right? Because this sets not just the gain, it also sets the output impedance, because that is the that's the path through which the signal is going to arrive, or well, the signal current is going to arrive. There is, the input impedance of this is essentially these little parasitic capacitances that exist, right? Like that. It's and so and that's the reason that as I actually turn this up, I like the halfway point best, because you almost sort of get the maximum gain at the halfway point, because as you turn that up further, this resistive impedance and this capacitive impedance forms a sort of a divider, and you get you start getting attenuation after the halfway point. So perhaps 200-ish 200k-ish variable resistor would be a better choice there, but I have 470k and it works fine. Okay, so now that's the second stage, and the reason I can get away with 10 meg over here is because I have a little trick, and the trick is this. So now we're getting into the solid state section, which is the power section. So that's the trick. I have a Darlington's buffer here, so that has very high current gain, meaning that this high impedance is no problem at all. And this is again 10 meg on top, 10 meg on the bottom. So here is that Darlington's pair buffer. It's a couple of BC547 transistors with this resistor and that one for biasing. And I missed a pretty important component, which is the coupling capacitor over here. There's a coupling capacitor, and that's a 10 nanofarad capacitor. Okay, so I hope that wasn't too confusing. 10 nanofarad capacitor over there. Yeah, okay. So now this output goes to a potentiometer. This is the volume control for the amplifier, and so that is a 100k potentiometer. And strictly speaking, this resistor here is not necessary because you have the path for current over here, but you know, that's just the standard way of doing things. So I figured, you know, why why do it a different way? Okay, so now then this goes into the main power amp, which is it's a Hi-Fi chip. It's the TDA2030 chip, and it's wired as a voltage follower, which means there's, you know, no gain here, 0 decibels of gain, if you want to put it that way. And there's another important component here actually, which is this. So that is a 1 microfarad non-polarized capacitor. It doesn't actually have to be non-polarized, but that's what I have. I have this film capacitor here, and that is connected. I don't know how well you can see that, but the chip is over there, and you can see it's mounted to a heat sink, which is obviously quite necessary. This is where most of the power in the circuit is going to be dissipated. It's just it's a piece of a door hinge. It's a piece of a brass door hinge that I'm using as a heat sink, and so this is a decoupling capacitor, which is necessary. It has a different role from this capacitor over here. So this one is for filtering. It's for ripple rejection, but this one is for decoupling from the power line. So it's for transient absorption in a sense. What that means is, since most of the power in the circuit is being consumed here, if there's a big transient, like you hit the strings a bit harder or something, and there's a sudden demand for a burst of energy from here, that demand can be partly absorbed by this. And if this wasn't here, it would be drawing that from the power line, and since the power line isn't perfect, that sudden load would propagate backwards and affect other things in the circuit, and it would be unstable. So my amp actually wasn't working without this. It was, you know, oscillating, and so this is an important component. Yeah, and then this just goes through a coupling capacitor. This is a big one. This is 2200 microfarad over there. This big capacitor there. And that goes to a switch, actually. Again, this is built into the output audio jack. So this is the output jack switch. And it goes to either the output speaker output jack, which I'm going to have some trouble drawing, but you know, it's like that and like that, and that goes to ground. I hope you can see that that's the output, or it goes to the speaker itself. And speaker is just it's a 3-inch sort of generic multimedia speaker, and so that's the amp. I don't think I'm missing anything. This is the indicator LEDs, the heater coils, and the actual audio amplification. And then this last bit over here with the switch and the speaker, all of that is inside there, you see. So that's the output. The coupling capacitor is there, and then this is the AC output from the amplifier going to this output jack, and then those 3 terminals over there are the switch well, it's one half of the DP/DT switch built into the audio jack, and so that switches it between either the output or the speaker. That's the amp. Now I suppose what I will do is I will cut in some footage with DI audio so you can see how that sounds.